In this lesson, first we are going to introduce the LCD 1602. So you will learn how to display a text, numbers, float, or any other characters that it can display. And we are going to learn how to scroll a text on the screen to left or right. And we are going to learn how to display temperature from DHT on the LCD. Going to measure the voltage from variable resistor or potentiometer and display it on the screen. Then we are going to use the ultrasonic distance sensor, measure the distance and display it on the LCD. Welcome to Arduino course by RoboJax. This course is based on SunFounder 3-in-1 Arduino kit sold on Amazon. Everything that you learn in this course is included in this kit. The course comes with tons of components and projects, all with instruction and video for smart car and other projects that you can use for school or home automation. You can purchase it from sunfounder.com. The kit also comes with full documentation, code download, learning projects with full explanation, wiring diagram, and the code that you can download. The link to purchase the kit and documentation is below the video in the description. This is LCD 1602, and this module at the back is called I2C or I2C, some people pronounce it, module, which makes it possible to eliminate using of this many wires to just turn this on. So we can just connect 2 wires for communication and 2 wires for power. So it needs just 5 volts to operate. This has 16 character space, so from 0 to 15, you see these squares, each is for 1 character, and we have 2 lines. For that reason, this is called 16, and then 02 means 2 lines. The same display is offered in 2004, where it has 20 characters and 4 lines, 1, 2, 3, 4. They are available in green and blue. So it has a backlight. We can disable backlight in some environment. If I remove this, the backlight will be turned off, and here the text is available, but there is no backlight. The brightness can be set using this variable resistor or potentiometer. Let me do it. Here I'm rotating it counterclockwise. So it is dark. Now clockwise, it becomes bright. So if you receive a display that does not show anything, do not worry. Just rotate this until you see the text. Let's remove the protective sheet so the reflection is reduced. The pins are labeled as ground, which will be connected to ground of Arduino, and then we have VCC. This will be connected to 5 volts, and then we have SDA and SCL. By default, this Arduino has SDA and SCL in here, that first 2 pin, and analog 4 and analog 5 are also SDA and SCL. Analog 4 is SDA and analog 5 is SCL. The I2C address can be set with these jumpers that you see here. When you connect them, it's called A0, A1, A2, and when you connect it, you will get different address if 1 is connected or 2 or 3. And here I'm going to show you how to select the address. So we have A0, A1, A2, and when we say A0, it means these 2 points should be soldered. When it's soldered, A1, A0 is 1. If it's not soldered, then this is 0, now 0, 0, 0. If we solder them all, it will be 1, 1, 1. Now, in this case, when it's 0, 0, 0, we are supposed to be getting A20. Right now it's 0, 0, 0. Like 0 is high and then these 2 low. In this case, this A0 do not just solder this and leave these two. And the same way, in this case, just the middle one soldered, which is high, so just solder this and leave the rest. In this case, A1 and A0, A1 and A0, just solder these two. So this is the combination of all binary numbers when you. And here is the wiring diagram. I've used fritzing to draw this. Ground from the top is connected to ground. The second pin is VCC. Let me straighten it. It's connected to 5 volts. SDA is connected to A4 and SCL is connected to A5. You can also connect it to SDA and SCL in here. If you pay attention here, ground is connected using this black wire to ground, VCC using red wire to 5 volts, and SDA is connected to A4 using gray, and using purple wire, SCL is connected to A5. This module needs a library, and you can get the library from robojax.com. If you come to this page, I will provide you the link. You will see that you can get it from robojax.com. Just click and get it, or you can get it from GitHub. From here, when I click, it will pop up. Just save it in your computer somewhere. Then on your using Arduino IDE, click on Sketch, include library, and then add .zip library. After that, point it to where you have saved it. I've saved it inside SunFounder. This is the library where once you found it, click and click open, it will be installed. After installation, click on File, Example, and scroll down until you see Arduino Liquid Crystal I2C library, and you will see these examples. One is Hello World and the other one is Blinking Cursor and Custom Character and Serial Display. So there are different programs available. This is the basic program that I have changed it so it can do many important stuff that you need. First, we are including the wire library. This is for I2C communication using include. You don't need to download anything. This is part of Arduino. This line is including the library that we have just downloaded. And then from this library class, this is a class of a program, we create an object called LCD, and then we pass the I2C address and the number of characters in the line, which is 16, and 2 means 2 line. Now, to get this address, we have to run I2C address scanner. Click on File, Example, and scroll down until you see wire. This is part of Arduino, and then I2C scanner or I2C scanner board. Just click and upload it to your Arduino board. Once it is done, make sure that the display is connected to Arduino properly. If it is, then open the serial monitor and wait. It will read the address for you. Here, I'm connecting another board. I'm just removing this blue, and this is green now. As you can see, it says not found. And I'm connecting the green, and it says the address is 03F. You see, that's different. And if I connect this larger one, which is four line, that was this. This is another blue, and this is 0x26, I believe. Yeah. So if the wiring is correct, you also get the address, and that's also an assurance that everything is okay. Now we have the address and the number of characters. In the setup, we just use the same object that we created here. We say lcd.begin, lcd.begin. So this is initializing the LCD, and this line lcd.backlight is turning the backlight on. Inside the loop, whatever we write, we will clear it. So we write lcd.clear. This is clearing the previous value that we have, and then we set the cursor at line 0, character 0. and here this is line 0 and this is line 1, and line 0 this is character 0, 1, 2, 3 up to 15. So we set the cursor in here, and then we type again next line, send LCD print. We print this text at this position, whatever position you set, and after that you say print, it will go to that position. Let me restore this. The text is already loaded. No, let me upload the code. So that text that we have is printed, and then in the next line we set the cursor character 0, line 1. So the cursor is set in here, character 0, line 1. That is line 0, this is line 1, and then we print this text that you see it in here. And then we have 500 millisecond delay, and the program comes and clears the screen for us and sets the cursor, prints this text, and the next line, and so forth. So this is the most basic way to print a text on the LCD. Now let's have a look at the other available examples. Click on File, Examples, and let's go to Arduino Liquid Crystal and select the first one, blinking cursor. Open it, and here the address is 027, that's correct. And let's upload it and see what it does. We don't need to even look at it, but I'm just showing you, and I will explain it if needed. So no cursor, and then here blink, cursor blinking like that. So you can have cursor blinking. So how you do it? We say LCD cursor, that is the function that we call, and while 1, this is a new thing maybe for you. While 1 mean while 1 is true, while this is true, 1 is always true, that means forever. So it will never even go to the loop. So this while loop will run forever, but inside the while we have a function which says first clear the screen and then print no cursor blank, and then after that it says no blank and blinking equal false. So this blinking that you see have been set here to be true, and it says true. If it is true, we see the text. After this it comes back to the while, and because this is false it goes to else, clear, and then it says cursor blank, and then sets it, and the cursor will blink, and then it sets it to true. So once it changes with blinking and it goes back, prints this with no blinking. When we want to have blink, we just put this line wherever you want to put it, because this is now after this text, immediately it goes after the text. If I want to just use it without anything else, let me clear everything, and let's put cursor blank and upload the code. That's it. So it is here. If you print something before it, it will be after that. So just put the cursor to wherever you want and it will blink. Let's go to another example. File, Example, I2C, and here it says custom char or custom character. Here we are defining a custom character. This is ball, and we are setting these values in order to draw a ball. And this is note, clock, heart, dark, check, cross, and red arrow, rectangular arrow, red arrow, whatever it is. So each line is one shape or letter or character. So this is, we have 1, 2, 3, 4, 5, and then 8 dots, and this is like a person with 2 hands and leg, and you will turn on and off each square to represent something. So this is called man, and here for that we have the head, one line, 1, 1, 1, 1, and then row 0, and then row 1 and row 2. These are all 1, and after that this is the neck, and here one character, and then all 5 in this line, and then all 5 in here, then 1 character, and then 2, like that. And how to use it inside the setup, here we have initialized the backlight and begin, and here we say create character 0 bell, and then character 1 note. Everything that we have here, they have been mentioned in here, and then we create. So 0 up to 7 character we can create, and then this says LCD home. The position goes from home, and then hello world, cursor 0, and then print I, and then write 3, and then let's upload it so we can see what it does. I love Arduinos, and then code and all these characters that you see, they are being displayed. So this is print. These are the characters that you can print. ROM code A00, and the display that I have is this one, so you can print only these characters, and plus the 7 more characters. But there is a version A02 where you can print all these characters, including these symbols. You see arrows and different letters, including Russian or Cyrillic. But for us, these are the characters, and they have defined these are ASCII characters. All the values are calculated like this. So to give you an idea, let's say you want to print F. Let me draw. So to draw F, we will look here at this, and we will look on this side. And this is number 1, and this is 2. Let's open calculator. And when you're in calculator, click and select programmer. So you will see this. Now, first 0, 1, 1, 0, go to binary, and let's type 0, 1, 1, 0 here. This is a code. After this, number 2, this is a code 0, 1, 1, 0 again. So this is just by chance, 0, 1, 1, 0. And we typed it, and as you can see, if I click decimal, it's 102. So remember that is 102. And here I'm typing below this. I'm just to print any of those characters, you use lcd.write. For normal text, you write lcd.print. So lcd.write 102, and I'm uploading the code. So let's see, once the code is uploaded, you see we printed small letter F. Just remember, 32 to 127 are ASCII characters, which means if you type 32, it will be one of the ASCII characters that you bring, then blank, 128 to 60 is blank, and 61 to 255 is Japanese ensemble. Go for the third example. Example Arduinos. Hello World was the one that we did. Serial display. Let's open this. So this will display the text that you enter in the serial monitor. Very interesting. Let's open it. First, let's upload the code. Let's see if the address is 27. Make sure every time you upload the code, make sure it's 27. Now there should be nothing. I don't know what will display. Yes, nothing. So I'm opening serial monitor, and here I'm typing. Let's say type J and press enter. When I enter J, it showed up. And let's put here book. Let me see if it can do 3 letters. Excellent. So it prints it, and it prints that check mark at the end. And here is the code. It says F serial available. Do this checks. Whenever you enter something, it will be true. then give it 100 milliseconds and clear the screen. It says as long as, or it means while it's available and it is greater than 0, then LCD write, serial read. Whatever is in the serial monitor, it will read it. So print the first one, second one, for example, in this case, book, B-O-O-K. So it writes book and then B and then O and O and K. And here, if you want to generate your own character in some other language, you can do so by just clicking and selecting what you want. Something like that. This will be one character. If you want to just clear it, you can clear. Let's say I've drawn R, and here are the characters that we need. We just copy this. If you want to invert it, pay attention. These values, it says 0, 1, 1, 1, 0. So all of the 0 will be 1, 1 will be 0. If I say invert, you see everything is black, and then we have this, which the value have been reversed, and it will just work fine. Invert, so you can go back. You can use this. And if we have I2C, it goes with this address, if it is blue, or if you want to see the hex. So this is perhaps what we want. And here I have defined this variable called count of type integer, and inside the code I'm getting the count and adding 5 to it. So this count will be adding 50 to it, and this count will be 50, and when the loop comes next time it will be 100 and 150 and so forth. And after the SunFounder, here this is a space, and then I put again serial print and count this variable in here, and you don't need to mention. The only thing is that you have to put a little space. Immediately it will be printed after that. So let's upload the code. So now every half a second that number is incrementing because of this 500 millisecond delay. If you want to put the millis, let's say millisecond, you can put it like that. From 1, and after 500 it will increase. So this is a second, because we have divided it by 1000. Now let's see how we can scroll the text either left or right. So in the code, let's say we want to scroll this text, SunFounder. I've written this for loop which goes from 0 to 45. 45 is the number of characters that we want to move this. If you see this, if this takes the whole screen, we will shift it 45 characters. And 45 characters, every character at 150 milliseconds. This delay is 150 milliseconds, and this LCD.scroll left will move it one character at a time. So it moves it and waits for 150 so you can see it, and goes to the next one and next one, and it does this 45 times and it will stop. And because we have a loop, it will come back and repeat the same thing. Here, if you pay attention, it just does that. And somewhere it will interrupt it with 45, because this is 16 characters, so you can do multiply of 16 with some numbers. Because we have used already the DHT11 temperature sensor and humidity, we were able to read it on Arduino, and we just learned how to use the LCD. Now we are going to display the temperature from this temperature sensor on the LCD like this, and also the humidity. And here is the wiring. Ground we connected to the ICSP and this pin, that's ground. VCC will be connected to the right pin. This is the positive, that's negative. SDA is connected to A4, SCL to A5. This is the case where you use only a resistor. So solder a resistor between the pins as shown here. I have soldered this resistor between the two pins. This goes to positive, the middle pin goes to pin 8, the third pin is not connected, the last pin connects to the ground. Like this. And here if you want to use, then from the left pin, a resistor is to a point where it comes back to pin 2. So a resistor is connected between pin 1 and pin 2. Pin 1 goes to 5 volts, pin 2 goes to 8, pin 3 is not connected, and pin 4 goes to ground. That was pin 5, and LCD is exactly the same. This is the code for DHT, and this is a custom code that I've just shown you for the LCD. And we are going to combine it, and we call it, let's first save it, save as. So I'm going to call it LCD and DHT 11 and DHT. Okay, so now this is for both. I'm going to copy code from here to this. This is the top of the code beginning and the LCD as and the DHT as well. So from here I'm going to copy everything before the setup. Control C, just come here before the setup and paste it. So we are done. Now inside the setup, this is for the DHT sensor. I'm copying it. Come here inside the setup. You see this is the setup. Between these two somewhere, just paste it. That's done. Now to get the temperature and humidity, this is temperature in Celsius and that's humidity. So that these three, I'm going to copy them and go inside the loop. This count was from before, I don't need a count, so let me paste it. I'm deleting this, it's just a text, basic text. So we have now the temperature, humidity, temperature in Celsius and temperature in Fahrenheit. We don't need this code. Let me close it. Let's call this temperature. Temp, just call it temp, and in the next line, immediately after that, we are going to print the temperature in Celsius. So this will print it, and let's also print one. Let's now copy this line and paste it, and let's call it degree Celsius. Let's say Celsius. For now, don't worry about the degree. We are going to print the degree and I'm going to show you. And then if you want Fahrenheit, just put here F and then put here capital F. And let's say for the second line, let's call it humidity. And one space after that. And let's paste. And let's just type H because that is humidity. Let's type here for percent or H, relative humidity. So that's it. Let's upload the code. So let me reboot this. Here is a temperature sensor and here is a display. As you can see, it shows temp with 2 spaces and humidity with %, 2 spaces, let's remove it, and send. So this will be moved to the left, yes. So 21 degrees Celsius. These are the characters for the LCD that you can print on the screen. And here we want to print this degree symbol. In order to do that, we have to find the value for this. So pay attention that we go at the top and we read 1101. And on the left, we see 4 ones. So 1101 and 1. So go to Start menu and type calculator. And from here, select programming. For this degree, if you go at the same line, you see 1101. Let's go to binary 1101. And then on this side, we have 1111. So continue 1111. And the value for decimal, if you click, you will see it that is 223. Let's go to our code. And just type 223. Instead of print, here you just say write. So every time you need to write any characters from there, you just say write, WRITE, and then the number. Let's upload it. Just wait. And degree appeared. So nice. Now DHT11 does not show the decimal point. So these are just some random number. So we want whole digit. That's also very simple. To do that, we just type integer and then our variable. In this case, let's call it TC. And the temperature which we want to convert it to integer, and it will remove the decimal points. Let's upload the code and see it. Let's see. Okay, so that's now fixed, and we are getting the whole number. The same way for the percent as well, we could do that. Now we have already learned how to read the voltage from potentiometer or pot or variable resistor, and we just learned how to use LCD. Now let's read the voltage from this potentiometer and display it like this here on the screen. And here's the wiring. We have learned already how to use this variable resistor or knob. I'm just holding it such that you see the one pin is towards myself, and this pin is going to be connected to 5 volts. The right pin will be going to ground, and this pin, the middle one, will go to analog 0. Like this. Now let's have a look at the code. So the main LCD code is the same. I have added this pot pin as a constant integer. Analog 0 is defined. Inside the setup, nothing. And inside the loop, I've used this analog read pot pin to read the analog 0. And the value of this is stored in a variable called value, and which is from 0 to 1023. And this doesn't mean it's voltage, so we have to convert it. We get the value here and multiply it by 5 over 1023. So this will give us a calculated voltage, which we'll store in a variable called voltage of type float. And then after printing this text on the screen, as you can see in here, then we set the cursor to character 0 line 1, we go to this line. This because this is line 0, that's line 1, and then we print this voltage with extra space, voltage and 1 space, and then we print actual calculated voltage, which is a variable that's here, and after that we print V at the end, so it looks like voltage. And here is the demonstration. As you can see, we are reading the voltage, and I can change it using my screwdriver. I'm going counterclockwise, so it goes to 5 volts. Let's go back to the right, and as you can see, it's responding very well. Now, because we are familiar with ultrasonic sensor and we just got familiarized with the LCD, now we are going to combine the code for the ultrasonic sensor so we can display the distance on the screen. Here is the wiring for the LCD with this ultrasonic sensor. The LCD is connected the same way. Ground is connected to this pin of ground. VCC is connected to the right pin, to the top pin of ICSP, and then SDA is connected to A4, SCL is connected to A5. For the ultrasonic sensor, ground is connected to ground. The left pin VCC is connected to 5 volts, and then we have echo connected to 11, and trig is connected to 12. And here is the code for ultrasonic. I've combined both of the codes. So this is for LCD for I2C, that's a library. We have defined number of characters, number of rows for the LCD. And this is the same as before. We have combined them. So the only thing different you will see is in here, inside the loop, we are getting the text, robojax.com, and we are setting the cursor at character 0 line 1, which is the second line, and we put the word distance. After that, if you count this, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10 characters, so 0 to 9, that's 11. So after 10 characters at character 11, we put the distance, and the distance that is measured, so which we got it from sonar.ping centimeter in here, and that will be printed, and after that we print the text. Let me upload the code. And here is a demonstration for the ultrasonic sensor. As you can see, we are reading the distance, and if I put my finger, it shows the distance perfectly. So that's the ceiling.